Right, okay, so in today's video we're going to have a look at 5 of the hardest questions on algebraic fractions. So grab a piece of paper, grab a pen, and we're going to get started. Now we're going to have a look at 5 different types of questions here. Some of them you might find easier than others, but they are pretty tricky questions and it's leading up to some pretty, nasty ones at the end. But we're going to have a look at all these 5 different types of questions. I've tried to make it a nice fair selection of different types of algebraic fractions questions as well. But this is going to be our first one here where we're looking at multiplying some algebraic fractions. Now it says to write these two fractions that we're multiplying together in the form ax plus b over cx plus d, where a, b, c and d are all integers, so all whole numbers there. So we're going to have a look at what we're going to do. Now when we're looking at algebraic fractions, we're always going to have a look to factorise if we can at any point, and there's quite a lot of factorisation that can go on in these questions, this particular question. So first of all, if I have a look at this top piece that we have here, we have 4x squared minus 9. Now that is a difference of 2 squares there, so we can factorise that. It goes into a double bracket. We get 2x plus 3 and 2x minus 3. There you go, obviously looking at some factorising quadratics there. Our factors of 9 are either 3 and 3 or 1 and 9, but there's no piece in the middle there, so that gives us our hint that it has to be 3 and 3. So on the bottom, let's have a look at what that factorises to. So 6x plus 9, well that factorises by 3, so we can take a factor of 3 out, and on the inside there we'll have 2x plus 3. Now that's quite nice because that means we can already simplify this fraction before we move on. We've got the 2x plus 3 there, which is going to cancel off on the top and the bottom. So before we even move on, we can already start simplifying that one. Now that's going to be multiplied by the one on the right there. So we've got 2x on the top, that doesn't factorise, so we'll leave that as 2x. And on the bottom there, we have x squared minus 3x, and that does factorise. It's not got a number at the end, so it's not going to go into a double bracket, but it does factorise by x, so we can take a factor of x out. So if we take the x out, and on the inside here, we get x minus 3. There we go. Now, unfortunately, that doesn't actually really help us because it doesn't cross cancel at all with the other side, but actually if we have a look at the top, we could simplify this a little bit further because the top and bottom of this fraction here both do divide by x. So if instead of writing 2x, look, if I kind of write it like this, if I factorise x out, you didn't have to write it like this, but we could factorise x out and we'd just be left with 2. Okay, just if it helps you to see it there, the fact that we can now just cancel these x's off and get rid of those. So if we rewrite what we've got left, we've got on the top of the left one there, we've got 2x minus 3, and that's all over 3. And on the right, we're going to multiply that by 2 on the top and x minus 3 on the bottom. There we go. And now we can actually go about multiplying these. So on the top there, we're going to have a single bracket, and I'm going to write it out. Probably wouldn't actually write this step out, but just so you can see what I'm doing, if we multiply the top, we've got 2 lots of 2x minus 3. And on the bottom here, we've got 3 lots of x minus 3. Right, there we go. Probably best to write it out so you don't forget to multiply both pieces by 2 on the top and both pieces by 3. But in order to get it into the form that it wants now, we just need to expand these brackets and obviously finish off our question here. So 2 times the 2x gives us 4x, and 2 times the 3 gives us 6, so minus 6. And on the bottom there, 3 times the x, is 3x, and 3 times the 3 at the end is 9, so that's minus 9. And there we go, that's our final answer. We've got it in the form that the question's asking for. Now we've got it in the form ax plus b over cx plus d. So a is 4, b is negative 6, c is 3, and d is that negative 9 at the end there. And that finishes off our question, 4x minus 6 over 3x minus 9. Right, okay, so that is our first question there. Not too bad, obviously just looking at that factorisation. I think there's a place in this question where you might potentially miss, and that might be this simplification here. And if you did miss that, you might have to end up factorising at the end there, which wouldn't have been the nicest. So you do need to have a look to see if you can simplify these fractions as you're going along. But there we go, that's our first question. Let's have a look at our second one. Okay, so this question we've got some adding and subtracting. So it says express these 3 fractions that are getting added and subtracted as a fraction in its simplest form. Now when we're doing adding and subtracting, we always go from left to right. So I need to start by adding these 2 together before I think about that minus 4x, 4 over x at the end there. So I need to create a common denominator for these 2. So I'm going to times the left one by the x minus 2, that right denominator there. I'm going to put this in a bracket as well. So times it by x minus 2. That's top and bottom, and the right one here, I'm going to times that by the x plus 1. There we go. Right, so on the top of that fraction there, we're going to have 3 lots of x minus 2, and that's all going to be over x plus 1, x minus 2. You can expand that if you want, or you can just leave it in a bracket for the moment. There we go, I'm just going to leave it in a bracket for the moment, just to save doing that step right now. And on our right fraction, we're timesing the top by x plus 1, so we have one lot of x plus 1, so rather than writing one brackets x plus 1, I'm just going to straight away write x plus 1 there. And again, we have that over our double bracket, which is x plus 1 and x minus 2. There we go. Right, so we can simplify the top of this left fraction, so rather than writing it all out again, I'm just going to simplify it over here. So 3 times x is 3x. And 3 times the 2 is 6, so it's 3x minus 6. And now we can add these two together. So if we add these two together, let's see what we get. We've got 3x, I'm going to highlight this, add the x, and that makes 4x in total. So we have 4x. And we have negative 6, and we're adding 1. So negative 6, add 1 is negative 5. So we have 4x minus 5 all over x plus 1 and x minus 2. Right, there we go. So continuing with that one, then now we need to take away this 4 over x. So I'm going to rewrite this. What do we have? We have 4x minus 5 over the x plus 1, x minus 2. And we need to take away 4 over x. Right, okay, so again we need a common denominator. So I am going to multiply the left-hand side by the x. So we're going to times the top and bottom by x. And on the right here, we're going to times both sides by the double bracket on the bottom there. So we're going to times it by the x plus 1, x minus 2. Now at this point it might be a little bit easier if I just expand that, but I'm just going to leave it as it is at the moment. I'm just going to write it all out, okay? So you can feel free to expand it if you want. I just want to avoid writing that, although at this point I'm writing it enough times that it's probably worthwhile me just expanding it. So actually I'm just going to expand this here and just see what we get. I'll start writing that instead. X times x is x squared. Then we've got minus 2x plus 1x, which is just minus x. And then 1 times minus 2 is minus 2. So I'm going to replace that just here with that double bracket. There we go. So I'm going to times that by x squared minus x minus 2. And again, that is the top and the bottom there. So let's go about timesing those. What do we get on the left numerator over here when we times that by x? Rather than writing a single bracket, I'm just going to go for it. So we have x times the 4x, which is 4x squared, and x times the minus 5, which is minus 5x. There we go. When we multiply the denominator, I'm thinking at this point maybe we might be a little better served not actually doing it this way, but let's just go for it. I'll keep it with the expanded form at the moment. We've got x squared minus x minus 2, and we're multiplying that by another x, which again you can expand if you want, but I'm just having a little thought that I'm going to leave it for the moment. So let's take away what we're going to take away on the right there. So we've got 4 lots of that quadratic. So that is 4x squared minus 4x minus 8. And again, that's all over this quadratic with the x on the outside as well. So we've got x squared minus x minus 2. Right, okay, well, before we move any further forward with our denominator, let's just have a look at tidying up that numerator. So what have we got? We've got a 4x squared, and we're going to take away another 4x squared, so they just cancel each other out, they're gone. We've got a negative 5x, take away a negative 4x, so negative 5, take away negative 4 is going to add the 4, so we've got minus 1x there. Let's bring this down here. So we have minus x. And we've got no other number, but we have take away the negative 8 at the end there. So be careful with that, because it's take away negative 8, so that's going to be add 8. So we have minus x, add 8, or 8 minus x. Right, there we go. So that's all over our bit on the bottom there. So let's see what we have. We have x, and we have x squared minus x minus 2. Okay, so at this point we just need to decide, can we simplify this any further? Because obviously the question says give it as a fraction in its simplest form. So at this point, having a look at the numerator, we've got negative x plus 8, that can't be factorised at all. And on the bottom there we've got our x with our quadratic in the middle. Now obviously we can leave it as that, but if we just try factorising that quadratic again, which we should already know because obviously we've expanded it earlier in the question, which is just here, then we can just put it back into that bracket and just see if it simplifies at all. So we've got minus x plus 8 all over, and we have an x, and then our double bracket that we had earlier in the question, so x plus 1, and that's not x plus 1, let's get rid of that, x plus 1, and x minus 2. So if we have a look now, top and bottom, we don't have any common factors, we don't have a common bracket there, we just have the negative x plus 8 on the top, and we have these three pieces on the bottom, and none of those cancel out, none of them simplify. So at this point here, we have fully simplified that fraction, okay? So actually, that question there is finished, that is our final answer, okay? And you can leave that factorised, or you could expand it if you want, although you're making more work for yourself if you expand it, obviously, which is why I was trying to avoid expanding it earlier in the question. But this kind of question here, it kind of looks like it's not finished, it doesn't look right, okay? So I think that's what makes this question look so difficult, in just that our final answer there just looks a bit bizarre. And we'd probably be looking at that in the exam, we'd be thinking, hold on, we must have done something wrong here, they must simplify more than that. But as it turns out, this question doesn't actually simplify any further. So just to let you know there, and so you can see that you do get some quite strange answers sometimes. And obviously, if you're happy with your methods and you're confident with all of that, then just to go with your answer and just be happy with that. Obviously, you always go back and check. But I think the difficulty in this question is this little part here, just making sure that when you did your takeaway at this point and you had your -8, obviously remembering that that turns into a +8, and there's little bits like that, and that's the sort of areas where we might make a mistake if we do on these questions. Right, let's have a look at our next one. Okay, so moving on to this question here, very similar to the one before in that we've got sort of subtracting algebraic fractions here, but we've got this sort of strange scenario at the start where we've got a 2 and not an actual algebraic fraction there, we've just got the number 2. But it says, show that this can be written in the form ax plus b over x squared minus 9, where a and b are integers, again whole numbers, and we want to work out the values of a and b. Now again, we have to move from left to right when we're adding and taking away, so we're going to deal with these first two pieces here to start with. So 2 can be written as a fraction, we could write it as the fraction 2 over 1. So if we rewrite just that starting bit, we've got 2 over 1, and we need to take away x plus 2 over x minus 3. There we go. So again, we need to make a common denominator. So we need to multiply the left fraction by that right denominator there, which is x minus 3. So we're going to times that by x minus 3, top and bottom. And on the right there, we're going to times that by 1. Which obviously isn't going to change that, it's just going to change that left fraction there. So 2 lots of x minus 3 is going to make 2x minus 6, not forgetting to times both those pieces by 2. And on the bottom there, we're going to have 1 lot of x minus 3, which just leaves us with x minus 3. There we go. And then we're going to take away this fraction on the right, which isn't changing because we're multiplying it by 1, so it's still x plus 2 over x minus 3, there we go. And now we can actually go about taking those away from each other. So again, just watch out on our numerator here because we're going to be taking away both these pieces. So we have 2x, take away the 1x, and that leaves us with x. And we've got negative 6, take away the plus 2, so negative 6 take away 2 is minus 8. And that is all over our denominator there, which is x minus 3. Okay, so now that we've finished with our first 2 algebraic fractions there, we can start having a look at obviously subtracting that third algebraic fraction that we have, the x minus 6 over the x plus 3. So if I rewrite this one over here, this x minus 8 over x minus 3, and let's see what we've got. So we've got x minus 8 all over x minus 3, and we're going to take away x minus 6 over x plus 3. Right, now again we need a common denominator, so we need to times the left one by the x plus 3 that's over there on the right. So we're going to times this by x plus 3, and again top and bottom. I have to keep saying top and bottom because I'm not writing it next to the top and the bottom there, but hopefully we know that with our fractions. And on the left here, we're going to times that by the x minus 3 on the left denominator. Okay, so on the top there, we're going to have a double bracket, and on the top of the right one as well, we're going to have a double bracket. So we've got 2 double brackets that we're going to have to do. And on the bottom here, we're going to have a difference of 2 squares, look, because we've got x minus 3 and x plus 3. Unfortunately, we spotted that at the start, hopefully, because we've got x squared minus 9 there. So that's going to be quite a nice one for us to simplify. So let's go about actually figuring this out then. So on the top, we've got x plus 3 and x minus 8. Now, if I write this all out, just to avoid skipping too many steps here, we've got x minus 8 and x plus 3, and that's going to all be over, and I'm going to expand that denominator now because x minus 3 times x plus 3 is going to give us x squared plus the 3x minus the 3x and then minus 9. So straight away we can get that denominator that we're looking for in the question. And we're going to take away, we've got x minus 6 and we're multiplying that by x minus 3. There we go, so x minus 3. And again, that's all over x squared minus 9, that same denominator there. Okay, so if we go about expanding these double brackets on the top then, our first one, we're going to get x squared. So x squared, we've got plus 3x and minus 8x. I'm going to do that in one step, that's going to be minus 5x. And then we've got minus 8 times 3, which is minus 24. And that's all over x squared minus 9. There we go. And from that, we're going to take away the other one. So we've got x times x again, which is x squared. Then we've got minus 3x and a minus 9x. That's going to make, the minus 3x and minus 6x, which makes minus 9x. So we have minus 9x. And then we've got negative 6 times negative 3, which is plus 18. There we go. And again, that's all over the x squared minus 9. Right, okay, so we just need to tidy this up. So let's have a look at what pieces we have. And again, we've got to be careful because it's a takeaway in the middle. So we've got x squared take away x squared. That cancels each other out, so that's fine. We've got negative 5x, and we're going to take away negative 9x. So that's one of those steps that you've got to be careful with. Negative 5, take away negative 9, and obviously just write these to the side at any point if you have to. Negative 5 take away negative 9 is negative 5 plus 9. And negative 5 plus 9 is 4, so we have 4x, and then we have negative 24, and we're going to take away the positive 18 there. Okay, so just obviously be careful when it is these takeaways that we obviously say that word takeaway before we look at that next number. So negative 24, and we're going to take away 18, so you need to just do that nice and carefully. Negative 24 take away 18 is negative 42, so we get minus 42 on the top there. And then we need to put that over our denominator, which is x squared minus 9. And there we go, that is our final answer. Now it says work out the values of a and b. So a is our number here in front of x, so a is 4. And b is our number at the end there, which is negative 42. So b equals negative 42. There we go, so technically they are our answers there. That's what the question was asking for, working out the values of a and b, even though, you know, here is our sort of our final algebraic fraction that we've got. Our actual answers are just up there. A is 4 and b is negative 42. Okay, so obviously just a few little places to be careful there. Again, it will involve this sort of takeaway at the end there. There's so many mistakes that you could easily make sort of in the moment of an exam when you're going through that. You just got to make sure that you say that word as you look at those similar pieces there. X squared, take away the x squared. Negative 5x, take away the negative 9x. And obviously, as I showed you, just write down the sums like I did here if you need to, because obviously when you're in the heat of the moment with a question like this, that's just one element that can really throw you. Okay, but there we go, that is that question done, and we're going to have a look at our next one. Here it is. Okay, so for our next question, we're looking at solving an algebraic fraction. So there's not many words that come along with this, we just need to solve it and find out what that value of x is. Now that value of x could be one value, it could be a few values, but we're going to have a look and see what happens throughout this question. Now at the moment, we've got to figure out what x is, but we've got two fractions involved that are getting added together. Now before we can move ahead with anything, we need to combine that, we need to get it all sorted and put together so that we can go about thinking about actually making this a single line equation with no fractions within it. So if we actually look at how we could go about that, we need to just have a look at the common denominator that we can make for these. Now there's some thing in this question that we can actually do to make this a lot easier for ourselves, and it's spotting that this denominator here can factorise. Now again, it is a quadratic, it's a difference of two squares, which we met earlier in the questions, but this one is obviously slightly different. We've got a 1 at the end there, and we've got a 4 in front of the x squared, so that does actually factorise. It becomes 2x plus 1 and 2x minus 1. Okay, that's one of our difference of two squares. And again, that's just one that you need to be wary of and have a look and make sure that you're happy to spot those when you see these occur. Now obviously part of that denominator is 2x plus 1. So actually in order to make a common denominator, we don't actually have to multiply the other side by that full denominator there. We can just multiply both sides, the numerator and the denominator, by this 2x minus 1, and that's going to give it a matching denominator there. So that's the difficulty with this question, because obviously if we did try and multiply both the top and the bottom by 4x squared minus 1, we'd end up making a cubic on the bottom of that left one, and that's going to be really nasty. Okay, so we can avoid that by actually just factorising that first and spotting now that we can just times this left fraction by the 2x minus 1, which is going to allow us to just have a nice quadratic on the bottom there, which is going to be a lot simpler for us moving forward. Okay, so there we go. Let's just get rid of that. There we go, 2x minus 1, and that's what we're going to multiply the top and bottom by. Okay, so now this question's actually not too bad. That is the difficult part of this question. If you didn't spot that, you could be sitting here for a long, long time trying to solve cubics and all sorts of horrible maths there, when actually it's a lot simpler than that. So if we actually just go about doing the top there, we've got 4 lots of 2x minus 1. So 4 times 2x is 8x, and 4 times the minus 1 is minus 4. And the denominator there is going to be that 4x squared minus 1. Now I'm just going to leave it as the 4x squared minus 1. I'm not going to write it as a double bracket because we already know what that's going to make. There we go. And we're going to add that to the one on the right. So that is 1 over the 4x squared minus 1. There we are. That's all equal to 3, but before I set it equal to 3, I'm going to add them together. So let's go about adding these together and simplifying that down. So we've got the 8x, which is not getting added to anything over there. There's no other x's, so we still have 8x. There we go. And then we've got negative 4, and we're going to add the 1. So negative 4 add 1 is negative 3. There we go, and that's all over 4x squared minus 1. Right, now we've combined those, we can set that equal to the 3 like it says in the question, and we'll have a look at solving it. So we have 8x, and I'm going to rewrite it down here, 8x minus 3 over 4x squared minus 1, and that is equal to 3. So now we've combined those two algebraic fractions there, we can actually just go about solving this like we would with any other sort of question that looks like this, okay? And that means that we need to get rid of that denominator, so we need to times both sides by 4x squared minus 1, or in other words, just times the 4x squared minus 1 up to here next to the 3. And that's going to turn this into a straight or single line equation. So when we do that, we have 8x minus 3, and that's equal to 3 lots of, I'm going to stick this in a bracket now, 4x squared minus 1. Right, there we go, so let's expand that. So we get rid of the bracket, so we have 8x minus 3 is equal to, and 3 lots of 4x squared is 12x squared, and 3 lots of minus 1 is minus 3. There we go. So we've got a quadratic going on. We want to make that equal 0. As long as it equals 0, we can solve it. So let's get rid of these pieces on the left. So I'm going to start by getting rid of the 8x, and I'm just going to do it in one step here. I'm going to also add the 3. So I'll do it in one step, in one step, but I'm going to talk through it a little bit slower than that. So we've got 12x squared. So taking away this minus 8x, and there's no x's on the other side, so we just get minus 8x. I'm going to slot it in there before the minus 3, obviously just to keep it in that normal quadratic format. And then we're going to add 3 to both sides, and if we add 3 to minus 3, that becomes 0 anyway, so it didn't matter that I slotted that minus 8x in. So there we go, that is our simplified expression there now, or our equation. It's now simplified down to equals 0, and now we can go about factorising and solving it. So at the moment both these numbers are even, so I mean you don't have to do this, but I think it just makes it a little bit simpler. So we can divide both sides by 4, okay, so we get 0 equals, we could do 2 and then 2 again, but it's just a bit quicker if we divide both sides by 4. So we get 3x squared minus 2x. There we go, and then we can factorise that. So if we factorise that, let's see what we get. Let's make ourselves a bit of space. Let's bring this up here. So when we factorise that, we get x brackets 3x minus 2, and that's what equals 0. And there we go, we can get our two solutions from this. We have the one solution there, which is just the x on the outside with no number next to it. So for that one, x equals 0. There we go. And for this one on the right here, just normal, like when we're factorising and solving quadratics, x is going to equal positive 2 over 3. There we go, 2 over 3. Obviously flipping the sign for the 2 there, but because it's a 3x, it's over 3. There we go, so there's our two solutions. We've got x is 0 and x is equal to 2 over 3. Okay, and just a little note on obviously when you're solving with these, obviously what we're trying to solve is when does 3x minus 2 equal 0. So if we add 2 to both sides, we get 3x equals 2, and dividing by 3, x is equal to 2 over 3. There we go, so that's where we get our 2/3 from, but obviously I did that quite quickly there, just making it positive 2 over 3. So there we go, there's our two solutions, and obviously thinking about what that means, it just means that if we sub 0 into our equation at the top there, it will equal 3, and if we sub 2/3 in, that will also equal 3. But there we go, there's our two solutions. Not the nicest there, because it didn't say find both values or anything like that, it just said solve, but in this circumstance here, we ended up with a quadratic, and when we get a quadratic, we are going to get two solutions most of the time, unless obviously both those solutions end up being the same. Okay, but there we go, that is our next question, and let's have a look at our next one. Okay, so this question is the nastiest looking one out of the bunch. Okay, it looks nasty because we've got these big square brackets in, and these big square brackets are quite a rare occurrence in the GCSE questions. Okay, so it does make it look quite nasty, but actually it's quite nice and simple. Now, the only reason the square brackets are in there is because we have a bracket inside the bracket there. So because we've got this x plus 5 inside the brackets, to bracket that off again, we've got these square brackets involved. So just in case you haven't seen those before, that just explains why we use these square brackets. Now, obviously we've got a similar looking question to what we had before, but instead of going from left to right, we're going to deal with everything within this bracket to start with. So let's just have a look at that bracket, and then we'll deal with this 6 plus that at the end. So just looking in that bracket then, we've got x plus 5, and again let's write that as a fraction, so that'll be x plus 5 over 1. And again, you can leave it in a bracket if you want. Let's just stick that bracket back around it, and we're going to divide that by our other fraction there. Now, before I actually write that out, what I'm going to do is I've just spotted that this top one factorises. So we'll factorise that. So our factors are 10, are 2 and 5, or 1 and 10. And in order to make plus 3 in the middle, we can use the 2 and the 5. We can have plus 5 minus 2. So that's going to be x plus 5 and x minus 2. There we are, that gives us the plus 3 in the middle, and that's all over x minus 1. So when we are dividing with fractions, obviously we keep the first one, flip the second one over, and we're going to multiply them instead. So let's have a look and actually go about doing that. Okay, so we have x plus 5 over 1, and we're going to times that by x minus 1 over what's on the bottom there. And in fact, let's just keep that in a bracket for the moment. So that's x plus 5 over x minus 2. There we go. So you could go about just timesing these together to start with. Obviously, if we times, all we're going to do is times the numerators times the denominators. But before we do that, we can cross cancel. You don't have to. You can times them together first and then cancel top and bottom. But we've got an x plus 5, which is going to end up on the top of our final fraction. And we've got an x plus 5 down here, which is going to end up on the bottom of our final fraction. So we can cancel those off straight away. So if we divide the top and bottom of x plus 5, this one here just turns into 1 because it's all that's on the top there. And obviously we've got our x minus 2 on the bottom of the other one. So we've got 1 times the x minus 1 over there. So that leaves us with x minus 1. And on the bottom there we have 1 again times the x minus 2. So that's just x minus 2. There we go. So that simplifies actually quite nicely. Now having a look at where we're going to go from here, we've got to add that to the 6. So let's move this along and just stick 6 in front of it. There we go, because we're going to add 6 to it. Now I'm going to write 6 as a fraction again, 6 over 1, and we're going to add to that this simplified fraction now that we've cancelled all that down and got it all nice and neat. So in order to add these together, we need a common denominator. So our denominator over here is x minus 2 on the right. So we're going to times the left-hand side, top and bottom, by x minus 2. There we go. And if we times that by x minus 2, 6 times x is 6x. Let's just show that that's where we're going. And 6 times 2 is minus 12. And on the bottom there, it's only a 1, so that's quite nice. That just becomes x minus 2. And now we can add that to the second fraction, which is x minus 1 over x minus 2. Right, okay, so just need to be careful again when we're adding these together. We've got a 6x add x, which becomes 7x. And we have negative 12, and we're going to add negative 1. Negative 12 add negative 1 is going to be negative 13. And that's all over x minus 2. And then let's have a quick look at the question. What does it say? Simplifies to ax minus b. So a is 7, b is 13. That's a little bit... you've got to be careful with that. If it did ask what b is, you've just got to be careful, look, because it says b minus b there, and we've got minus 13, so actually b is just 13. Okay, so just watch out for the symbols there. It's not actually asking that, but if it did, just something to be thinking about. C is our value in front of x on the bottom. There's no number there, so that's 1. C is 1. And d, again, we've got a negative d, negative 2, so d would be 2. Okay, it's not actually asking for that, but just thinking about if that scenario did occur and it did ask, that would be our answer. But there we go, there's our final answer, 6x minus 13 all over x minus 2, and that is our final question of these 5 questions. Now, well done if you've got this far, because I actually have one more little bonus question to have a look at, which looks nasty, and I'm just going to show you a really easy way of solving this question, okay? But it's actually not necessarily one of the hardest, but I think if you look at this in a nice way, it's actually one of the easiest out of all of these. Okay, but just a little bonus question to finish off with here. If you manage to get through all these, well done. So here it is. Okay, so for our last little question here, we've got some solving again with algebraic fractions. Now on the front, this one looks quite nasty, and it's actually not that bad at all, okay? And with this sort of question, normally we would have to combine this algebraic fraction at the start, and then we'd have to look at cross multiplying with our fractions on either side of the equal sign, okay? Normally when we're solving algebraic fractions like that, they can be quite nasty and just take a little bit of time. Now for this particular question, there's something quite nice, and that's the fact that these denominators, 4, 3 and 6, all have a nice common lowest common multiple, okay? And 4, 3 and 6 can all turn into 12. And if we make these all out of 12, I'm going to show you a nice little trick for actually solving this type of question quite simply. So if we times this first fraction here, top and bottom, by 3, again with times in both those pieces on the top, we get 9x minus 6 over 12. And we're going to take away, and we're going to times top and bottom by 4 this time, again to get 12 on the bottom. So we get 8x plus 20, and again that's all over 12, and again if we do it to the one at the end as well, so times that by 2, we get 2 minus 2x all over 12. Okay, there we go. So if we now go about combining what's on the left there, so if we just combine these numerators now, we've got a 9x take away x, which leaves us with 1x. And we've also got negative 6, and we're taking away 20, so just be careful with that. So negative 6 take away 20 is negative 26. That's all over 12. There we go, and that equals 2 minus 2x all over 12. Now if these denominators were not the same, or we've got some algebraic pieces in the denominators there, what we'd have to do at this point is we'd have to cross multiply. So we'd have to times the 12 up to here and the 12 up to there, and start to get some slightly larger numbers and sort of have to solve that from there. But because these denominators are the same, and because we've made them the same, we can do a little trick. We can just times both sides by 12, and that's going to remove this divide by 12 that's going on both sides. So if we times both sides by 12, it's just going to get rid of these, and all we're left with is x minus 26 being equal to 2 minus 2x. There we go, and that saves us an awful lot of working out with this type of question. So now we can solve this quite nicely. We can just go and get the x's on one side. So if we add 2x to both sides, we get 3x minus 26 equals 2. Now we can add the 26 to both sides. So add 26 to both sides, we get 3x equals 28. There we go, and now we can solve that, okay, by dividing both sides by 3. And if we divide both sides by 3 now, we get x equals 28 over 3. Okay, so obviously we've got the answer 28 over 3 now. We could actually think about writing that as a mixed number if we wanted to. It doesn't ask us to in the question, but obviously if it did, we could actually go about just making our answer look a little bit nicer there. 3 goes into 28 9 times, up to 27, so it's 9, and we've got 1/3 left over, so we could have our answer as 9 1/3. Okay, it doesn't actually ask us to do that in this question, so it's fine for us to leave our answer as 28 over 3, but obviously normally we'll leave our answers as mixed numbers and fully simplified and all that, so we'll leave that as 9 1/3 there, or 28 over 3. Okay, but that is the final answer to our last question there. Just thought that was quite a nice one to finish on, just with a little trick looking at those denominators. Obviously that doesn't apply to all these sorts of questions, but because we had these numerical denominators there, we were able to apply a little bit of a trick, and just thought that was worth having a look at before we finish on this little topic, and maybe a little bit of a nicer one to finish on, because some of these have been pretty tough on these algebraic fractions questions. But that's the end of the video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.